Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 9-2, exponential functions. Alright guys, so a general exponential growth function has the form of f of x equals a b to the x minus h plus k, where b is greater than 0 and a, h, and k are real numbers, with a greater than 0. Every value of b represents a different family of functions that can be transformed by changing the values of a, h, and k. The general exponential decay function has the same form, but 0 is less than b, which is less than 1. Alright, so it says to use your graphing calculator to help you with this activity. Since we don't have a graphing calculator, I'm just going to go like that. Although I kind of want to look at this real quick. So it says like to graph f of x to the 2x. Okay, so this is f of x. 2 to the first. 2 to the first is 2, right? So if x is 1, you get 2. 2 to the second is 4. So if you plugged in 2, you get 4. If you plugged in 3, 2 to the third is 8. You get 8. So this is the basic parent function of f of x, y equals 2 to the x, right? So if I'm taking that, and I'm going to do this next one, 2 to the x minus 4, right? What's going to happen here with the g of x? What do you guys think? The x minus 4 goes 4 to the right, to the positive direction. It's left or right, opposite of what you would think. So that's 4 right. So you literally go over 1, 2, 3, 4 to the right. Does that make sense? That's g of x equals 2 to the x minus 4. What do you guys think happens for this one? For the plus 6? Which way do you think it's shifted? For x plus 6. If x minus 4 is right 4, what do you think plus 6 is? Left 6. So you literally would go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Does that make sense, guys? I can prove it. If I plugged in, on this one, if I plugged in a 4, 4 minus 4 is 0. Anything to 0 power is 1. So 4 comma 1. You guys see how that works? You can also just plug and chug. Alright, so what do you guys think happens here? If you had f of x equals 3 to the x, what happens if I have a plus 3 off to the side? You're going to shift it what? Up 3. And what is the minus 5 off to the side? Down 5. Alright, so what do you think happens when I have a 3 out front? What does that 3 out front do? Vertical what? Stretch. What do you think the 1/2 does? What do you think the 1/2 does? Vertical what? Shrink. Good. Okay. So how about here? Compared to the parent function, what's going on here? Compared to f of x equals 2 to the x. This part does what? Down 7. What's the plus 1 do? What's that plus 1 do? Left 1. What's the 4 out front do? Stretch or shrink? So it has a vertical stretch of 4. It's being shifted left 1, down 7. compared to the parent function. Make sense? All right, so graph each exponential decay function. All right, so we have g of x equals 1/2 to the x minus 5. So normally we're getting as close as possible to the x-axis, right? But this one's being shifted down 5, right? Being shifted down 5. So we're going to get as close to -5 as possible without ever touching it, right? So my axis is, what's it called? My asymptote, instead of it being here at 0, it's 1, 2, 3, 4, 5 down. All right, so instead of this being at 0.1, I'm going down 5, right? So let's think about this. If I plugged in a 0, anything that's a 0 power is 1. So I'd have 1 minus 5. 1 minus 5 is -4. See how it was 1 above that asymptote? It's still 1 above the asymptote. All right, so now what if I plugged in let's say plug in a 1. If I plug in a 1, 1/2 to the first is 1/2. 1/2 minus 5 is -4.5. Right? It's going to get as close to this line as possible without ever touching it. What if I plugged in a -1? 1/2 to the -1 minus 5 is -3. What if I plug in a -2? -1, and so on. Make sense? You guys see how you can plug and chug? You have a calculator, plug the numbers in. So what's going on here? This is going to be shifted how much? It's going to be shifted left 2, up 1. So instead of being at 1, 1, left 2, up 1. You should have -2, 2. Let's double check. Anything that's 0 power is 1. 1 plus 1 is 2. That makes sense, right? It's shifted up 1. So my asymptote's up here. So it's going to be getting as close to this line as possible without ever touching it. And then let's just put in another point. So if this is the original, and we are right here, and we're going left 2, up 1, we should have the point -4, 9. Let's check. -4 would be -2. 1/3 to the -2 plus 1 is 10, right? What did I say? -4? -4 plus 2 is -2. 1/3 to the -2 plus 1 is 10. All right, so it should be there. And that should be good for graphing. Just need a couple points, right? How is the graph g of x equals 0.25 x minus 3 related to the graph of f of x equals 0.25 to the x? So what does that x minus 3 do to this one? Shifts it what? Shifted what? The minus 3 on the exponent. Shifts it what? Left or right? Right 3. It's opposite of what you think, right? So what does this one do? Shifts it what? Plus 3 does what? Left 3. How does the graph of x minus 3 relate to the x plus 3? They're going to be 6 apart, right? They are 6 units apart, horizontally, right? All right, so if I have g of x equals 4 times 0.25 to the x, first the parent function First graph the parent function, then graph the graph of f of x is shown at the right. Okay, so they have the parent function already there. The graph of g of x is a vertical stretch of the graph of f of x by a factor of, what's the vertical stretch by a factor of what? Vertical stretch by a factor of what? I'm waiting for you guys to answer me. 4, good. Use this transformation to sketch the graph at the right. So the only thing is a vertical stretch of 4. So instead of up 1, it's up 1 times 4 is 4. Instead of here, let's see. Instead of here at 4, 4 times 4 is 16. It's going to be super steep. All right, so we can plug and chug and stuff like smaller numbers. So if I plugged in a 1, 0.25 times 4 is 1. If I plug in a 2, 0.25 squared times 4 is 0.25. It's going to look like this. If I plug in a negative 1, 0.25 to the negative 1 is 4, times 4 is 16. It's like super high, like it's not even on the chart. Okay. So let's look down here. So for B, the parent function is f of x equals 1/2 to the x. How are these related? Well, this one is going to be vertical shrink by a factor of 1/2. Right? How about here? What's the difference between these two? What's this one? Vertical what? Stretch by 9. How about here? Vertical what? Shrink by 1/3. That would be a shrink by 1/3. That's a stretch by 9. So what are they really? The graph of h of x is a vertical shrink of the graph of g of x by a factor of what? Think about it. So it'd be 1/9 and 1/3. 1/9 and 1/3, 1/27. You see how I did that? 1/9, 1/3, 1/27. Right? 1/9, we get it to nothingness, and then 1/3, we get it down that way. So that's stretched by 9, shrunk by 1/3, so 1/9, 1/3 would put it back to there. 1/9 times 1/3 is 1/27. Yes. Yes. All right, guys, so use the property of the exponents to explain why this graph may be considered a vertical stretch of this graph. Okay, so what is the factor of the vertical stretch? All right, so we're really doing what to this? We're shifting right 3, right? But we could look at this as g of x equals 1/2 to the x minus 3 is 1/2 to the x times 1/2 to the negative 3, which is 8 times 1/2 to the x. Right? Because 1/2 to the negative 3 is 8. And that's why it's considered a vertical stretch by a factor of 8. That one was a little weird. All right, so let this, okay, first find the value of k. Since the graph of y equals 0 is the horizontal, y equals 1 is the horizontal asymptote, we know that we're adding 1. We're shifting it up 1, right? The horizontal asymptote, instead of being 0, is at 1, so we know that we had shifted it up 1. Find the value of a. The y-intercept of the graph is 3. Right? You guys agree? Okay. If the graph is translated so that the x-axis is the asymptote, the y-intercept of the graph will be 2. It's normally would be 2, right? The y-intercept of the parent exponential growth is 1. This means the graph of the parent function is vertically stretched by a factor of, if it should have been at 1, but now it's at 3, oh no, sorry, now it's at 2, right? Then what are we going to have? 2. It's at 3 because of it being shifted up 1. So if we shift it back down, it would have been at 2. And 1 times what is 2? 1 times 2 is 2. Find the value of b. The graph of g of x passes through 1, 7, right? We have the point 1, 7 right here. So, if the graph is translated as part A, then it passes through 1, 6. Shrinking produces the graph of the parent function passing through 1, 3. So the graph of the parent function passes through 1b, so b equals 3. Write the equation. So you're going to have 2 to the 3x plus 1. It was shifted up 1. It's vertically stretched by a factor of 2. Your y-intercept is 3. All right, guys. So you are going to do your best on pages 511 and 512. I hope you enjoyed today's lesson. Please like and subscribe and have a fantastic day.